Welcome everyone to Friday of Astronomy Days week. I'm Carrie, I'm an educator at the museum, and I'll be your host for this program. So we have an icebreaker question for you. So consider Mars. So if for anybody, a human going to Mars, it's going to take a year to get there. There'll be about 6 to 12 months on planet, and then another year to get back. So about 3 years. If you got the opportunity, would you go to Mars? So while you're answering that, put those answers in the chat. I'm going to go through a very brief Zoom tutorial. First, this program is live captioned. If you'd like to use the captions at the bottom of your screen, you'll see where it says closed caption. Click on that and then click show subtitle. And then the subtitles are going to look like this on the bottom of your screen. Up at the top right, there's a view options button. If our videos are over the presentation, click that and then choose side-by-side mode. That moves us over so you can see the whole presentation unobscured. This bar over here between the slideshow and the videos is movable, so you can make the presentation really big or you can make us really big, whatever your preference is. And then at the bottom, of course, is the chat box. So we want to hear from you. Give us your questions, make comments, just keep it on topic and be kind and respectful to everyone in the chat box. So with that, I'm going to stop sharing and let's see, are we going to Mars? I know my answer. No way.
There's some great answers. I love some of the answers. I think the favorite one is sounds like a great retirement idea.
Yeah, absolutely. No, too old. I don't think I can sit still that long. I'm sorry. I mean, I love reading and I imagine you'll have lots of time to read, but 2 years on ship. Oh, no.
I would just hope there's a big window. I just need a big window to look out. That'd be the big thing.
I mean, it would be cool, but 2 years looking out the window is a long time. Anyway, thank you, everyone. So let me introduce our speaker today. So Adam Hauser is a NASA JPL Solar System Ambassador, and he's here to tell us all about InSight. So Adam, take it away.
Thank you. And I think I need to go back to sharing my screen. Let's see here. Okay, and we'll pull my, there we go. So welcome everybody, thank you for coming. My name is Adam Hauser and I am a NASA JPL Solar System Ambassador. It's a really great volunteer program put on by NASA and JPL out of Pasadena, California. And as I mentioned, I'm here to talk about the Mars InSight lander. This is pretty exciting because this is actually the third time I'll be talking about this, landing back in 2018. So we've been able to get a lot of science done on Mars, and we're still up there, still operating. We've had some successes, maybe some difficulties and things, and we'll kind of cover those over the next 45 minutes. So what we want to kind of break this talk down into is giving you a recap of InSight and the actual mission itself. We'll talk about the first 772 sols or the first 793 Earth days on Mars. And then we're going to break down 2021 on Mars and kind of let you know where we're at right now and what we've discovered in 2021. There we go. All right. The InSight is kind of unique. I think everybody is aware of the rovers that we have on Mars, whether it be Perseverance, Curiosity, or Spirit and Opportunity back in the day. Oh, poor Spirit and Opportunity. But InSight is unique because it's actually a lander. Its goal was to land on the surface of Mars, stay in one spot, and do science right there. Its goal wasn't to move around, look for signs of life. InSight is all about studying the surface of Mars, or the center of Mars and the interior of Mars to really figure out how Mars was formed. And so the main scientific goal is to understand the formation and evolutions of rocky body planets, much like Earth is, Mars is similar, and study the interior of Mars using seismology, precision tracking, and heat flow. So those are the three main scientific things we wanted to investigate. And when you have three things you want to investigate, you'll need some scientific instruments to do those. InSight itself actually has a whole bunch of little experiments on it. It has a lot of technology on there. It allows us to communicate with it all the way from Earth to Mars. Of course, the neatest thing is it has a robotic grappling arm. It has a camera on that arm. It has a claw on that arm, as well as a little grappler that's able to retract, and that allows it to set instruments on the surface of Mars. Has two big solar arrays. I have to admit, this was probably not the best background choice because it looks like I have giant Dumbo ears, but that's actually InSight behind me. I'll just have to move off to the side a bit. It's got temperature and wind sensors, so we can actually measure the temperature on the surface of Mars, as well as wind directions and velocities. Has a pressure inlet, so we can detect the pressure on Mars. An antenna for communication, the RISE antenna, which is one of the primary instruments. Has a camera facing more towards the Martian surface, so we can see where we can set the instruments. And then it has SEIS and HP Cubed, and those are two of the other main instruments that we're going to talk about here momentarily. We're going to kind of dive into those a little bit more. Overall, InSight has got a 19-foot wingspan, so it's actually pretty big. It's 5 feet wide, and it weighs 794 pounds, and it's about 33 inches tall at the bed, up to 43 inches tall with a grapple arm. And the arm itself is 5 feet and 9 inches long. So it gives it a pretty decent reach outside the bed of InSight. So the first instrument I really want to talk about is RISE. It's the Rotation and Interior Structure Experiment. And this is kind of a unique idea. Basically, what we're doing is we're using radio tracking, really precise radio tracking, measured from Earth to Mars on the top of InSight, to basically see how that distance between Mars and Earth changes, to figure out how much Mars wobbles or spins on or off its axis as it rotates around the sun, much like Earth does. Easy for us to measure here because we have instruments everywhere. But on Mars, this is a way for us to be able to figure out how much it wobbles in its orbit. The next instrument is really cool, and this is the seismometer, and then it's covered with the wind and thermal shield. So SEIS for short. Listens to seismic waves to investigate the interior of Mars. This is one of the instruments that's really done the most work on Mars and continues to do work on Mars, detecting not earthquakes, but Marsquakes, because they are on Mars after all, which kind of always throws me for a loop. And then the wind and thermal shield is placed over SEIS to protect it from the wind and the environment. SEIS is so unbelievably sensitive that you need to have SEIS over it to make sure that wind, even though with the really low density of the atmosphere on Mars, the wind on Mars doesn't blow like the wind here where it can knock you over necessarily. But even with that lower density atmosphere, we needed to make sure to protect SEIS so we wouldn't get any false readings. And last but not least, probably one of the most interesting and most courageous experiments on the InSight lander is the Heat Flow and Physical Properties Probe. So this was called HP Cubed. If you think of a manual handheld staple you may have or your parents may have, it's got a big metal handle on top. And you squeeze it and it shoots like wood staples, staples into wood. So you can staple tarps or Christmas lights, stuff like that. That's kind of the same technology that HP Cubed actually was using to drive this mole up to 16 feet below the Martian surface. It's actually attached to a tether that goes back to the main part of the instrument. And on that tether, they have little heat sensors every 14 inches or so. And then at the actual mole itself, it has a little electric piece that's able to give off heat. So the idea being is you burrow this mole 14 feet or 16 feet into the ground, have it give off heat, and then you can actually measure how the heat dissipates through the Martian surface all the way back up to the surface, and find out how the at least 16 feet of the crust of Mars is made, how it's composed, how dense it is, and all those kind of things. And of course, in the recap, we'll talk more about what actually happened to the little mole. InSight was launched on May 5th, 2018. It had a nice about 6 or 7 month cruise stage into the summer and fall of 2018, approaching in the fall of 2018, and ultimately landing on Mars on November 26, 2018. Almost immediately, it started beginning the scientific mission from activating RISE, opening its solar panels, and kind of getting settled into the Martian surface. Very, very excited to say that InSight is not the newest robot on Mars. Perseverance landed back on February 18th last year. And so we've got We got another rover on Mars. This one's Perseverance, about the size of Curiosity, about the size of a car.
So
InSight itself
so we have a
landed
question, Adam. Oh, sorry, we have a question.
Sure.
So somebody, Jan's asking, have any of the rovers gone to the polar caps of Mars?
No, Phoenix is the close. That's the most northern. There are certainly a lot of challenges getting up to the poles of Mars. That gets into the orbital dynamics and how to actually get there and stuff. And I can't say, is getting to the poles possible or impossible? I'm not 100% sure, but it's certainly a lot easier and a lot more readily available to get to the equatorial, more equator-based areas of Mars. Certainly, getting to the poles would be huge, as that's where we're going to find ice, possibilities of water ice, along with other chemicals and things. But no, Phoenix is the farthest north we've gotten. Perseverance is pretty far north for a rover, actually, and you'll see just to the southeast of it is InSight.
Very cool. And
so
I have one more
sure.
question. Mm-hmm. You can do it. So Stephen is asking, do the stats on quakes suggest a limit, or are we just waiting for a magnitude 7 or 9 quake we've not heard yet?
We will get into that, actually.
Okay.
That's something that the scientists have been wondering.
Hold your horses, Stephen.
Throughout
we'll
all
get
this.
to
So
it.
if you don't mind, yep, I actually have a couple. We'll talk about a couple of those Mars quakes.
Oh, and Ruxin's
so
asking,
InSight landed at Elysium.
Oh, and Ruxin's asking, where's Sojourner on here? We don't see him.
Ooh. Oh boy. I wonder why it's not on there. I don't know. I can't pretend to know, and I do not know. I will have to find it and add it to it.
Good job, Ruxin.
Busted.
Okay.
See, this is where if we're in person, I'd have like awesome NASA stickers or something like that to dish out for the question. Yeah, I do not know. I do not know.
Oh, that's actually
right, so
Stefan pointed out it's Pathfinder, because Sojourner didn't go very far from Pathfinder.
Oh, that's right. That's right. Because it was just a rover off of it. I was not thinking about the actual main core mission was Pathfinder.
Now you get the NASA sticker.
Thank you,
Stefan.
Now I got to brush up on the history there. Perfect, guys. Thanks, y'all. Yeah, we're not perfect. We there's so much to remember and to keep track of now. And I mean, there's actually a launch here in a couple hours tonight from Cape Canaveral with SpaceX. There's so many launches we can't keep track of them all anymore. All right, any more? Nope. Good. Okay. All right. So InSight landed at Elysium Planitia. That was, let's say, November 26, 2018. And what was unique about InSight is we weren't looking for a geographically exciting area to land in. We were just looking for a nice, flat, no rocks, very, very safe place to land, because the science that InSight wanted to do or needed to do was all about the core inside Mars. We weren't interested in the surface. We didn't need to look for neat rocky areas. We didn't need to look for dried lake beds, anything like that. All right. So the first 772 souls, we had a very, very exciting first 2 years on Mars. That was the first picture. This was the instrument context camera. This is the camera on the underside of InSight that would actually take pictures of the soil there to see where we're going to deploy the instruments. This picture was taken just a few days after it landed on November 30th. And we knew we were good. We knew we were on the ground, and we landed in such a way that there weren't any big giant boulders in our way, just some small little pebbles here and there. So we got the solar panels open, started generating power, and we're able to really kick in some of the instruments. So RISE started first, and RISE's actual scientific mission was to last 2 years, gathering data and understand Mars's wobble better. After RISE had kicked on, it was time for the instrument deployment and for InSight to kick up its arm and actually stretch and take a look around. So these are some of the first pictures that the camera on the robotic arm were able to snap of InSight. So you'll see there's SEIS in orange. Behind that is the WTS, the wind and thermal shield. And then off to the left there is the carriage for HP cubed, which actually the tall black part has HP cubed in it. And of course, you'll notice all those little grabber balls on the top of those three instruments, and that's where the grapple would actually grab those instruments to deploy them on the surface of Mars. The camera was able to go up in early December of 2018 and take 52 individual images and actually figure out, kind of map out the work surface, figure out where we're going to deploy these instruments. And then back here at JPL in California, scientists were able to actually kind of build that surface using a sister ship to InSight and actually test deploy all those instruments before they actually did it on Mars to make sure everything would go smoothly. So really, really cool. In December is when SEIS was placed on the Martian surface. That was December 19th, 2018. And then it was released several weeks later on January 4th, 2019. It then itself lowered and leveled itself in the middle of January 2019, and the cable was dropped and adjusted on January 30th, 2019, with the wind and thermal shield being placed over it a few days later. And then finally, the HP cubed was placed on February 12th, 2019. And hopefully this will play for all of you. So this is actually not video. This is just still images stacked on top of each other to kind of make a simulated video showing how InSight actually deployed all these instruments on the Martian surface. One of the coolest claw games I think you could ever possibly play. And now it should be noted that all of this actually happens in a pre-programmed manner. Someone is not actually on Earth controlling the robotic arm. All the programming has to be done in advance for the robot to drop these, for the robotic arm to drop these experiments on the surface of Mars safely. So a lot of programming, a lot of testing, everything went into that. By August 16th, 2020, we actually had a bit of an issue with RISE. It had stopped, some of the weather sensors had stopped providing data. The cause was unknown, but like anything, turn it off, turn it back on again, and it started working again. So happens to NASA. On January 14th, 2021, RISE had been collecting data since shortly after landing, and this data is still being studied to understand how Mars actually wobbles and how it affects the orbit of Mars. I haven't seen any major papers or any major releases on that data yet. On January 14th, 2021, SEIS had a successful deployment and operation, and SEIS has detected an interference interference in its data from the mole being set so close to it. And so they've also had noise from the tether. You can see the strip that's going along to SEIS from the lander. And scientists had kind of figured out that the expanding and contracting of the tether due to the sun hitting it, due to it heating and then cooling, was actually causing interference in SEIS's readings as well of the Mars quakes. So in January of last year, there was a plan to basically cover that tether with Martian soil using the scoop on the end of the robotic arm to protect the cable. And now we get to HP cubed. This, in terms of all the developments, everything that happened with HP cubed since March till January 2021, you could literally make an entire movie, maybe a series of movies off of it, as it was more drama than your daytime soap opera. In the first hammering attempt, the mole reached an estimated depth of 14 inches, which basically means it was not even fully submerged into the ground. It's still sticking up several inches. We thought we'd hit a rock at that point in time. Scientists were pretty convinced that, hey, we must have hit a rock because it's just not going anymore to the surface. Additional hammering attempts were made, but no progress was made. Scientists were able to determine that the mole itself had actually gone off at an angle into the Martian surface, so it's kind of stuck in the actual carriage. They decided the best course of action would be to actually remove the carriage off of the mole, to attempt to actually push it in with a robotic arm using the bucket, and to try to push Martian soil over to actually get it to stay in the Martian surface. Those attempts allowed it to crawl back into the ground a little bit, reaching a depth as far as 1 inch below the surface. They would start hammering again and pop right back out. Push it back in, hammer again, pop right back out. That went on almost for the course of an entire year. You can see them actually pulling the cartridge off of the mole, being able to see the mole and see that it was still actually protruding from the ground. Here's a little bit of a closer up, again, a video of still images showing just how wide the hole had actually been made in the Martian surface. I don't think anyone was expecting the Martian soil to be that loose or for the mole to make that big of a hole into the surface. By August 2020 to January 9th, 2021, the robotic arm had piled soil on top of the mole, trying to keep it down into the Martian surface. They had actually pushed the bucket on top of it again. The robotic arm was used to create friction within the soil. But by 500 hammer strokes later, with no progress at all, the team had to call the mission, end the mission, save power on January 9th, 2021. The final depth is approximately 1 inch below the soil. And from there, I have not heard of any attempts to release heat from the probe. I think at this point, they pretty much had to just kind of cut it and save the energy. As you'll find out coming up in 2021, energy has been a bit of a difficulty due to dust on the solar panels. So that brings us to 2021 on Mars. It was so difficult here on Earth. Why would we expect anything different on Mars? February 2020 of last year, so this was just after I did my second update last year at Astronomy Days. InSight and Mars were moving towards the Martian winter, aphelion, which is where Mars is actually the farthest point from the sun. So that means power generation is going to be at its weakest. InSight is a solar power or a solar driven instrument. And so it needs that dust off those solar panels in order to collect more energy. Also, more power has to be saved to heat the instruments on board to make sure they don't freeze. There's wild temperature swings on Mars. And so in the nights, the cold nights, cold days, you'll be able to keep some of that energy, those instruments, keep them warm. A unique test was developed with the solar panels, with one of the solar panels, to actually see if they could get some dust off of it. The solar panels actually kind of rolled up like a round accordion, if that makes sense. And they have the motor actually was able to turn a little bit. And so scientists sent the command for the solar panels to kind of pulse back and forth, kind of waving so slightly, to see if that would shake any of the dust off the solar panels. But that didn't work. It didn't really do a thing. And then someone came up with a really interesting idea, which was actually just using the Martian soil from the scoop on the robotic arm to dump that soil onto or next to the solar panels. So here's a demonstration on top of the wind and thermal shield, actually dumping some Martian soil on it to see if it would actually remove the dust that had collected on top of it. And that did work, but they can't directly drop that soil on the solar panels, so something else would have to be tried. During this time as well, in March of 2021, scientists had begun the process of burying that connector and burying some of the cable that goes out to sites to protect it from the wild temperature swings. This would help eliminate some of that false data in sites and detecting Mars quakes, as well as reducing that, expanding and tracking the cable. So not only did they dump that test load of dirt on the wind and thermal shield, but it also helped cover some of that connector. And you'll see in further pictures, up to more recent pictures, there's been quite a lot of scoops of dirt actually dumped on the connectors and dumped on that cable. So here's the first compilation test of actually taking Martian soil, dropping it next to the solar panels from as good a distance as they could with the robotic arm, and hoping that the Martian wind would actually grab some of that dirt, some of that soil, blowing it across the solar panel, actually cleaning off some of that dust. And you can see in these compiled images that we keep replaying that as it dropped the dust, you can actually see more of that black solar panel right towards the very end before it repeats. And the team at InSight had actually detected an instantaneous bump in power when that happened. So the kind of wild idea of, hey, let's dump some soil next to it, see if that helps blow it off, actually worked. And from that point in May 2021 to now, there's been a couple more attempts. We'll talk about it doing that. In June of 2021, some of the very first big scientific discoveries were released as white papers. It was 3 main scientific white papers that were peer-reviewed and released in June. And SEIS has given us all that data. So this is all from Mars quakes within Mars to know what's going on with the crust, the mantle, and the core. Scientists found that the crust, and now these are, of course, are very long white papers with a lot of really good, amazing detail. They are publicly available, so you can go to the Mars website, insight.mars, to get them. But I'm just going to very, very quickly summarize maybe 60 pages down into one sentence, which was the scientists found that the crust was much thinner than they expected. It was it's still, they're still not 100% sure if it's broken down to 2 or 3 sublayers, but it may go as deep as 12 miles if there are 2 layers, up into 23 miles if there are 3, but still less than even half of what they thought it was actually going to be in terms of its depth. Beneath that is the mantle, which extends down 969 miles below the surface. And at the heart of that is the core, which has a radius of 1,137 miles. So actually pretty substantially large, and it is molten. So we have been able to confirm that the core of Mars is actually a molten core, which is absolutely amazing to know, because now we know that when it comes to rocky body planets, the 2 out of 2 we've been able to study all have a crust, a mantle, and a molten core. So there's a lot that can be determined from that, and a lot we can continue to study on. August 2021 was Mars quakes. That was the highlight of the month. InSight had detected its 2 largest quakes on the same day. So someone had asked a question about larger Mars quakes. Up until this point, it's only been like 3.2, 3.3s that SAIS has been able to detect on Mars. However, in this day, we got a 4.2 that occurred about 5,300 miles from InSight and consisted of slow-moving, very low-frequency vibrations. But then shortly after that, a 4.1 less than 600 miles away from InSight occurred, and it had really high frequency, really fast vibrations. That wasn't that long ago, so I'm very interested to see what scientists determine from these 2 earthquakes happening in the same day, having such different frequencies, different speeds. There's going to be a lot of really good data they're able to dive through on that from SAIS. Seeing some of the weather on Mars has been really amazing. Even though this wasn't some of the main purpose, in September, we were treated to a really beautiful composite video of some of the clouds moving over InSight. And it's just beautiful. I mean, exploration sometimes gives us really wonderful things. And just seeing that, there is an atmosphere on Mars, albeit it's a lot thinner than ours. There's still a lot of activity. There's still a lot going on. It's still really a pretty amazing, magical place. That brought us to a really unique period that happens every 2 years with any of the scientific exploration we're doing on Mars. So whether it be an orbiter, whether it be a rover, whether it be a lander like InSight, every 2 years, Mars and Earth get at what's called conjunction. And that is where Mars is on one side, you have the sun in the middle, and you have Earth on the other side. This makes it very, very, very difficult to communicate with spacecraft, not because of the distance or anything, but it's because the sun is right in the middle. And so if we were to send commands to InSight or Perseverance or Curiosity, there's a chance that the ionization of the sun could actually mess with those signals and could actually send faulty commands to those spacecraft, to the lander, to the rover. And so it'd be very dangerous during this time to send commands to the spacecraft. Now we can have the spacecraft send commands back to us, and that's fine because we can kind of determine what's going on if there's faulty data or anything. But it's just kind of dangerous to do that. So during this time, every 2 years, between October and October, I can't remember if it runs to November or December. My apologies, my brain slipped on that, how long it lasts for. I want to say it's just the beginning of or end of September. It's maybe like 2 months. But before that happens, so actually in September, we will actually send to the spacecraft kind of homework, if you want to call it, so things for the spacecraft to do during those days when we can't reach the spacecraft, when they can only send stuff to us. And like I said, it happens for all the scientific equipment on Mars. And it's just something neat to kind of bring up that during that time, SAIS was just continuing to collect data. So we were able to collect some Marsquake during that. And same with Perseverance and Opportunity. They're just kind of doing their things, doing their homework, so to speak, as some of the scientists call it. We did more dust removal in November of last year, and that was allowed us to get actually a little bit more power out of the spacecraft, out of the lander, And so that got us through the end of the year last year and into January of this year, which we're still at the Martian winter, which kind of brings us to where we're at now. And we got some really, really good news 9 days ago. And in the earlier part of this year, with the soil, the dust still on top of Insight's solar panels, we're still not getting the full charging capability we want to. And that forced Insight to go into safe mode. That low power state only allows the necessary instruments to be powered up. That means we can't have the robotic arm doing thing. We can't really have sites doing a lot of extra measurements and things. We just kind of have to keep it in the bare minimum. On January 10th of this year, so in early January, Insight went into safe mode. It means we just didn't have enough power to run everything. So basically it kind of shut itself down, preserved all its power for its heaters, all the things it basically needs only to survive, and that's it. On January 10th, we were reporting that the power was still good. So we were still using some power to keep itself warm and things, but we weren't seeing any unexpected drain or anything. And extremely exciting news, I say 9 days ago, Insight was able to go out of safe mode, resuming normal operations. However, we're not conducting any science at this point. We're still going to take a few more weeks to actually see what power is coming into the solar panels, kind of give us a power allowance to figure out what we could do next, whether we can fire sites back up, get Rise back up and going, and see what more data we can collect. The original mission of Insight was only supposed to last 2 years. So at this point, Insight has done far more than we thought it would do. We've been able to get a really good amount of science bang for our buck, so to speak, and we continue to get more as it'll hopefully function more on Mars through this first half of the year. And that's everything I've got for the update on Insight. Do we have more questions?
Yeah, so folks, if you have questions, go ahead and put them in the chat. Jan had a question. Does Mars have a magnetic field?
I do not know. Okay. Yep, I do not know. I would have to think we do, but I cannot say. I can't say definitively without looking it up and researching it. So okay. I would have to look that up and see. I am not 100% sure. So we'll have to look that one up and see. I apologize, but I don't want to say incorrectly.
So okay, and then Keenan has a question. So how much longer do you think Insight is going to be operational?
I'm really hoping we make it through all of 2022. Depending on how much more soil we can drop on top of the bed to clear the solar panels. I still think there's a lot of seismic data we can record. It was asked earlier, when are we going to see that big 7.0 or something like that? That's what I just hope Insight can get. There's a lot of data you can collect from a Mars quake, almost said earthquake, a Mars quake that large. And so I really hope we see something bigger than that 4.2. It's just a matter of kind of waiting for it. So if we're able to stretch a whole nother year out of this, maybe I could do an Insight update number 4. I'd be incredibly happy. At this point, though, there's still so much wonderful data that we have to dive through. You can go and look on the Insight webpage that's run by nasa.gov and see all the raw images and just see how many amazing images Insight has collected. And that's not even the data, it's just images. So I really hope to see we make it through 2022. It's all going to depend on the power, though, on those solar panels for sure.
Yeah, absolutely. So I have a question. So what's causing the Mars quakes? Does it have like tectonics, like Earth?
Well, we now we know that it has some kind of tectonics that are causing these quakes. Obviously, with the core being molten, we know that that's going to create shifting and create movement. I know some of the early Mars quakes that were detected as part of my presentation last year. I removed a lot of the scientific data that we discovered over 2020 to 21 to talk more about 2021 this year. But I do know a lot of the Mars quakes actually had detection center points of what their depths were and things. And so I do know we're figuring out more about of tectonics, how they may work, where they may be located, things like that, to really figure out how Mars, kind of moves in its own way.
Very cool. So Marcel wants to know, do we have many tricks left to try and get the panels cleared off?
I don't know. If I would have loved to have been in the room where someone suggested dumping dirt on it to see if that blows it off, because I just think that's the funniest thing to me, because it seems like you would make it so much dirtier.
Yeah.
If you actually go look at some of the raw images of InSight, you can see these like piles of dirt sitting on top of the bed. And I just don't know how someone said, let's dump some Martian soil on top of our beautiful, beautiful lander. So
I know. I'm thinking
and
of
actually
that.
Carrie and I had a conversation.
Yeah. I'm thinking of those air things,
right?
that you like spray on your keyboard.
Yep.
That robotic arm
Yeah,
needs
Carrie and I had a conversation about this a month ago or so, talking about ways to plan for this more. Even some of the initial things that people think about, like those solar panels, for example, I mentioned, are actually accordions, so it rolls back back shut and then folded back into the spacecraft. So why can't they just fold them up, shaking the dirt off and fold them back out? But the problem with that is, if they don't fold back out, now the mission's completely dead. And so you've got to be able to come up with solutions that aren't going to reduce the lifespan of the mission or harm the mission. And one of the great things about it is we do have Martian windstorms and sandstorms. So we do occasionally have events that'll actually clear off those solar panels a little bit. Other new ways, other new ideas on how to get rid of it. I don't have any, but you never know what idea might come up next.
I know. I feel like this is one of those problems that we all just are so eager to try and solve, right? It feels like there should be a solution out there. So Stephen is asking, How did that work? How did dropping the dust dropping the dirt on it remove the dust? Was it like the particles were charged and attached a bit so they got repelled off? Or
that's an interesting question. I don't think anybody would be able to say that definitively if they were charged or anything. It'd be tough to know. It certainly could potentially play a role, I guess. But what they did, so when they dropped the soil on top of the wind and thermal shield, they dropped it directly on that, and that's what cleaned it off. But with the solar panel, if you remember, it was actually dropped on the bed next to it. This is where I wish I was in person to maybe point out. Let me see if I can use my mouse here. The Martian soil is actually dropped kind of, you really can't even see where it actually hits the surface of the top of the Martian bed, or of the bed of InSight. But from dropping it from there, this is done during the kind of the windiest parts of the day. So they looked at all the different atmospheric and weather data and kind of picked a certain time to do this, knowing it would be the windiest, what direction the wind has been blowing and things. So as this soil was dumped, they were hoping it was going to be windy. They kind of had a general idea where it was going to blow, what direction it would blow from. And as the larger dirt particles, which are much larger than the dust particles, fell and were blown by the wind, it's kind of like a snowball effect where those larger particles kind of grabbed some of the dust and took it with it. And that's basically how it worked, which again, kind of is what's so maybe amazing about it is who thought of that. And I would think then that, yes, some kind of charge those particles may have as they're falling and rubbing across the solar panels, things might help them stick together and things, just kind of like dust does here on Earth. But I can't
like a dust bunny
say that for sure.
Like,
but
you know how the dust bunnies form in your house?
Yeah, it's I mean, yeah. Oh, I have no idea what you're talking about.
Yeah, I was gonna say, yeah. I don't have any of those. So Jan is asking, how do they decide where to land them? So how do they, like, I think referring to both InSight and the rovers, and will they get a closer look at that huge trench?
That would be awesome. There's it's hard to say. There's so many amazing places to see throughout our solar system. And without question, one of the hardest questions to answer, I think, for anybody at NASA or any scientist a part of these missions is where to put the spacecraft, where to put the rover, where to put the lander, what orbit to fly in if you're gonna be a reconnaissance orbit or something like that. And with InSight, it was unique because, again, it was all about the inside of Mars. So we kind of wanted the simplest, most boring, safest place to possibly land, and that was definitely Elysium Planitia. Planitia in Latin means, I think, it's like the flat plane, and then Elysium means like afterlife, heaven, I think, or something. So basically, a super flat, super safe place to land. With the rovers, it's much, much, much different because the rover does all of its science on the surface. It wants to look at rocks. It wants to drill out cores. It wants to see striation of different layers on Mars to see what different rocks or composites may lay up in be in those layers. So that's why dried up lakes, dried up rivers, and things that we think are dried up rivers, dried up lakes are really great places to explore with rovers, where you can kind of drive over there, take a look here, take a look there. But there are a lot of debates internally. I've never, unfortunately, had the privilege of getting to be a part of those. They would never want my opinion, but you can read a lot of really amazing books. Red Rover is one of them, talking about which places they picked for Spirit and Opportunity to land. Knowing they had two rovers, they wanted to pick two really amazing places. Same with Perseverance, same with Opportunity. Even back in the Apollo days, there was a lot of discussion of where to land all the Apollo missions on the moon to try to maximize the safety while also maximizing the science, but then also maximizing the ability to explore. What is it we may find there?
Very cool. Everybody has lots of ideas about dust. Marcel is saying, is ingenuity too far away to help?
Try them out at home.
I know.
We talked about just having a big brush or something like that. I mean, we've had ideas. I've sort of ideas of a spinning solar panel that could just spin.
Fan. You can just
360 degrees. Yep, and just have a brush on it or something like that.
Come on, NASA.
The thing to remember.
It can't be that hard.
The thing to remember is everything always has to have a definitive time frame and a definitive operational period to some degree. We always like to get budgets. We always like to get better bang for our buck. We like to see our dollar be stretched further. NASA, JPL, a lot of the people who in the universities who build these robots, who are taking taxpayer money to do the research or do the studies, everything kind of has finite definitions to it. And so that's why even with InSight only having a 2-year lifespan, NASA can't spend a lot more time or a lot more money, or even more importantly, a lot more weight or energy consumption on the spacecraft to try to prolong the life even further than was originally designed for. These all have an operational design period. So, hey, this needs to last for 24 months. This needs to last for 36 or so on. The fact that Spirit and Opportunity lasted so long shocked everybody. And even Curiosity is really doing great on Mars. Now, Curiosity and Perseverance are a bit different because they're run on a nuclear, essentially a nuclear reactor. So they're ultimately at some point their power will go out and that'll be it. There's no solar panels to recharge or anything like that. So as these spacecraft are designed, budget, time frame, cost are all major things. And so as much as we all would love to see something that would clean the solar panels, a lot of this stuff gets pushed off because it won't fit the budget, won't fit the weight requirements. And we already are pretty confident that the spacecraft is going to far outlive its original operational design.
Yeah.
But it doesn't mean coming up with fun ideas isn't cool.
I know. So Stephen says, when the dust landed on the area next to the panels, the bolts look like they stayed clear somehow. And that's making me think, I read an article many years ago about somebody who had invented a toilet out of a material that bacteria couldn't adhere to. And so I'm like, well, that's it. We just need a material that the dust just can't adhere to. It just slips right off. There you go.
Well, and to mention again, this the dirt, the image is actually a bit deceiving on the depth. The Martian soil itself is actually dumped a lot further into the picture. So where you see the bolt being cleaned is the bed of the spacecraft, the bed of the lander being cleared off along with the solar panel. You have to go back to those raw images. I think there's only one or two good raw images that shows that pile of dirt actually sitting on those cables and things. But it's 6 to 12 inches or so more into the bed of the spacecraft. So it's not getting dropped directly where those bolts are.
Mm-hmm.
But you can see the effect that the bolts have had, or how the color has changed, the blackness on top of the rover has changed from that red, oxidized dust color to more of a black.
Very cool. So anyway, I'm sure that material would put it over budget. So well, folks,
and please, and don't forget, everybody. You can go on the. I think Carrie, you're gonna actually have some websites or some links for everybody that we can share.
Yeah, Nancy's been dropping them in the chat
on those. Oh, perfect. If you go to the Mars Insight main page, you'll see all those raw images. You'll see all these videos. All the pictures, all the documentation, everything I have is all property of NASA JPL. So it's all free to share, free to look at, free to use. And so check out those images, though. They're really amazing. And the questions that I wasn't able to answer, please look them up and see. There's always things that you can learn every day from just going to the NASA.gov website or diving into all the little individual missions.
Thank you so much. All right, Stephen has one more question. What core exploring science should be done next?
Oh, that's a tough one. There are so many. Oh my goodness, there are. the geology on Mars is the opportunities to study geology on Mars are literally limitless. Not that necessarily I think we'll discover anything totally radically different than here on Earth, but it's that we can compare them to Earth to learn a lot more on how these rocky planets form. It'll be a long time until we'll get to study a rocky planet in another solar system. Mercury and Venus, we can do a little bit of studies, but you're not getting near them. You're definitely not getting to the surface. And of course, obviously with the gas giants, there's I guess technically a gas surface, but you're not going to be able to study that. So Mars is really our best opportunity to help us understand the similarities between Earth and Mars and how rocky bodies form. I think realistically, the best way we're going to study the core is when we get to Mars. I think that's the only way we're really going to be able to study more of it. Until we're able maybe to drill down a couple miles, something like that, and actually really find out how heat dissipates, all that kind of stuff. That's probably some of the next geological studies and things we can do. I'm not sure what the next geology-based lander or something that would land on Mars to study more of the interior of Mars would look like. And that's a great question. That's a great area of research. And if any of you are, still in high school or still in college and you're interested in geology, the planetary sciences are an unbelievable area of study. It's where I did aerospace originally, and I would go back and do geology in a heartbeat because it is just so unbelievably fascinating. The things we can learn, and that doesn't even start to cover all of the moons. We've got Titan, we've got Ganymede, we've got Io, we've got all these Enceladus. We have all these amazing moons that we can study that have a geology all their own. And now those are places where you might find just absolute wild geology that has nothing to do with what we'd find here on Earth or on Mars.
So exciting. So
extremely excited.
It is really exciting to just think about how much is left to discover, right? I feel like we've barely scratched the surface. We've come so far, but we barely scratched the surface, right? With our knowledge. So David has a question. Best guess, how long before a human will walk on Mars?
I don't know. It's a discussion that happens probably every day. Like I said, there's so many SpaceX launches right now, I can't even keep track of them. I've got probably half a dozen apps on my phone to keep track of all the launches and missions and things, and I still miss them. It's going to be very interesting. Artemis is really kind of kicking in high gear. So we're going to see how that does. That'll of course get us into out past low Earth orbit. Hopefully, get us around the moon again. You've got SpaceX doing all they can. You've got Blue Origin. We've got all these different companies looking at finding ways to get more humans into space. But I'm 38 now, and I'm feeling pretty confident that I'll see someone land on Mars in my lifetime. More so than I ever have been in the past.
It's exciting to think about because everybody here said they'd go. So.
Yeah, no, I think I only saw like 2 no's. So
right. I think one of them was me.
Change is the projection of how long it even takes to get to Mars and come back, and how long you have to stay to make it worth it, and so on. All might change in the future. We know you got to pretty much spend 2 years on Mars, give or take, based on the distance between Earth and Mars to actually be able to get to Mars or back from Mars, and maintain some energy efficiency and things like that. But that'll be completely different, as we continue to learn more and develop new engines and new methods.
So, all right. Well, thank you so much. What a wonderful presentation. We have all learned so much and enjoyed this so much. And Mars is just a magnificent place. So
amazing.
Thank you Thank you so much for telling us about it. And we're going to solve the dust problem at Astronomy Days this year, I think. So, so Adam, it's been fantastic.
No, that would be if we get face to face, we'll do some experiments with that next time.
Yeah. Oh my gosh, Astronomy Days 2023. We're gonna do the dust. We'll do the solar panels, and we can all experiment on different ways to knock that dust off. It sounds so fun.
I love it.
All right, so I'm going to. Oops, sorry, I'm slow. Here, I'll just do that. So I thank you guys all for coming today. We do have Astronomy Days t-shirts if you want to commemorate the event this year. They're Venus shirts, and they are very cool. So they are at the museum store, either in person or online.
Very cool.
Yes, I know. And we I do want to thank our sponsors, North Carolina Space Grant and Pepsi. And I want to thank our museum members. If you are a member, thank you so much. Your membership supports programs like Astronomy Days. And if you're not a member, please consider joining, because it really, the support that our members give to our programs is not insignificant. So thank you very much. And our last program of today is Return to the Moon. It's at 6:00. So I hope to see everyone there. So have a great rest of your afternoon, everyone. Bye-bye. Thank you.